So first of all, I'd like to thank all the attendees for giving us your time. I know everyone is busy with the different types of things that you do, but you joined this session. Some of you joined even 10 minutes early, and you're showing a lot of enthusiasm, as the organizer said. So we'll try our best from our side to make this worth your time and make this a very good learning experience for all of you. So our goal is to really talk about Wi-Fi technology in general and starts from the basics and try to also talk about some advanced concepts and technology concepts and so on, but in using easy examples and easy to understand way. So as the organizer has said, this is a long course. We have many sessions planned, and so we hope you come along with us on this journey. And today's session, we are going to start with introduction and history of Wi-Fi. And we're going to specifically talk about how Wi-Fi technology evolved over the past 25 years or so. Right. So let's get straight into it. The next slide. So some of you might have seen this pyramid of basic human needs. It's also called Maslow's pyramid of basic human needs. We all need various things like food, water, shelter, safety, security, and so on. And a lot of people, if you see online, would say that Wi-Fi is right up there in the basic human requirements these days. So I don't know about you guys, but I have 2 kids, my daughter and my son. My daughter is around 7 years old, and she can go an entire day without food. She'll never complain. But if the Wi-Fi in the house is not working for 5 minutes, then she'll start coming and kind of screaming and saying, okay, Wi-Fi is not working. I need to watch my favorite show or something. So in many ways, for the younger generation, Wi-Fi is just a part of life. Wi-Fi is just a part of what you do, and it's everywhere, right? And it's used ubiquitously. So for a lot of you, you could be engineers, you could be already working in Wi-Fi technology, or you might be new to Wi-Fi technology. It is still a very fascinating technology, and the objective of this course is to take you along the journey to understand the fundamentals of Wi-Fi and how things work. So for example, you take your phone, and this is a Wi-Fi router, right? So you connect your phone to a Wi-Fi router in the house. When you connect, what happens? How does the connection process happen? What packets get exchanged? What information get exchanged over the air between this router and this device? When you move far away from the router in your house, what happens? Do you lose signal? If you lose signal, how do you maintain connectivity? And what happens there? Let's say there is another Wi-Fi router in your neighboring house, and that is interfering with your Wi-Fi router. How do you handle that situation, right? So you are streaming video, and you have many videos you want to stream. How does that perform on the Wi-Fi router? Security. When you connect to the Wi-Fi router, you use a security mechanism. How does that security connection happen? When you type in your password, how does that authentication happen? So like this, there are so many concepts that are related to Wi-Fi. Even though you're completely new to the technology, we will try to explain a lot of these things in as simple terms as we can. And we're also going to dive into how the technology evolved and what are the various business cases and how business actually drove the technology over the last many years. So as far as this course goes, as I was just saying, the idea of this course is not really, if you're coming from an academic background, we're all used to taking classes where there are a lot of formulas, definitions, equations, and so on. We're not going to have even one equation or one formula in this entire course. And I'll try my best not to have that. And everything is concept. We're trying to explain the concept of how something works in the most simplest term possible. We are going to explain complicated concepts, but we're trying to explain it in the most simple way possible. And then we are trying to relate that to how it is used in industry, because I come from an industry background, although I have a lot of experience in the academic side, but the last 20 plus years I've been spending in industry. So we will bring the industry applications into every concept that we explain in this course, and we try to explain it as easy as we can. So who is this course for? This is for anyone who is in a junior mid-level engineer working already in the Wi-Fi industry, or anyone who is pursuing their master's, bachelor's degree and have interest in the area of computer networking, wireless communications, and so on. So you certainly will find this useful. And also, if there are any academicians and some faculty members also registered for this course who are interested in developing a more industry-focused course and are looking for material, and some form of training, you can certainly use this course as well. Prerequisites, certainly a lot of interest in this area. If you already have some basics of computer networking from academics, if you have prior certifications like CCNA or CWNA, those will be very useful. If you have some basic understanding of wireless communications, digital communications from your coursework or from your work, that will be awesome. And if you already have some knowledge of Wi-Fi standards and protocols, even better, right? So all of that will be useful for this particular course. Right, so what does each session cover? So each session would be about 45 minutes to 60 minutes long. We'll try to stay within the 60 minutes time frame for each session. And we will cover a set of theoretical concepts relating to that topic of that day. And then we'll try to explain those concepts in as real world examples as possible. And if there is any way we can show some practical demos of the concepts using certain tools, then we'll do that. Through the session, we'll have some fun quizzes and things like that, and we'll try to. It's hard to keep the session interactive when so many people are joining, but whatever we can do to keep it interactive, we'll try to do that. Of course, this course is completely free for anyone to attend, and the material that we create is all going to upload on the website. You can download it for free. The videos are going to be recorded of all the sessions. They're going to be uploaded on our YouTube channel, and the links will be posted on the website, so you can certainly use them. And then, given the amount of information we have on the internet, it doesn't really make sense for us to recreate every image and every diagram and every table and everything from scratch. It's going to take us a lot of time to do that, and we all have our day jobs and we are busy with our other work. So several of the images that we are going to use are going to be copied and used from the internet, because they're readily available. There's no reason for us to recreate them. But wherever we are using images and content from books and from the internet, we'll try our best to acknowledge the source so that they get credit for that. And certainly we don't intend to use this material for any commercial purposes. So so there's no commercial aspects here. The course will be delivered entirely online through using Zoho app. And then the meeting links and calendar invites will be shared ahead of time. So a little bit about me. My name is Sitarama. I currently work as the Chief Technology Officer of Candela Technologies, and I also run the India unit of Candela Technologies. And my entire work experience is in the field of Wi-Fi and computer networking. So for the last 20 plus years, I started off at the academic side, and then worked at research labs. Worked on the standards bodies and things like that, and then went into software development and developed a lot of technology and products in Wi-Fi testing area, and then went into the business side, technical marketing, and then product management, and then running Wi-Fi businesses. Over my journey, I worked with hundreds of companies all over the world that work in Wi-Fi technology, companies that make Wi-Fi chipsets, companies that make Wi-Fi routers, companies that deploy Wi-Fi devices, companies that test Wi-Fi devices, work with so many companies all around the world. And that gives me generally a bigger picture of how this industry works and how this technology works. And through my time, I've conducted several training sessions, boot camps, seminars for the organization that I worked in over the last several years, and helped train a number of people in this particular area. So I hope to use that knowledge and experience to actually try and deliver this course. Since this is a long set of classes over a long period of time, I'm sure you'll get bored of listening to me. So we'll try our best to invite guest speakers wherever we can. Anyone who is a technology expert in a specific area, we'll try to see if we can invite some experts. And if one of you who is listening right now, would be interested in presenting a session or contributing material, please do reach out to us, and we can certainly work together. Okay, so since this is the first session, I'll just very briefly go through the course material, course plan, and then we'll jump right into the contents of today's session. So module 1 is all about history and introduction of Wi-Fi technology. So today's session, we're going to talk about evolution of Wi-Fi, the various generations of Wi-Fi, how the technology evolved from a very, very basic, simple set of features to all the complex set of features that we have right now. And then we're going to talk about the various ways in Wi-Fi is deployed, network topologies, And then week 2, we'll touch upon Wi-Fi standards. So this technology is so ubiquitous because of standards. Everything is standardized, and there is a lot of innovation and a lot of process around creating technology standards. So I'll dive into how standardization works, how the IEEE works, and how various governing bodies and other bodies like Wi-Fi alliances and standards committees work in creating the Wi-Fi standards that we use today, right? And then week 2 will end with a very high-level anatomy of a Wi-Fi access point and router. So this is, of course, a Wi-Fi router, as you can see, one of the many types of Wi-Fi routers we have. So we are going to open this up, and we'll show what's inside, right? And what are all the blocks that are inside this Wi-Fi router? What is a radio? What is a baseband? How the various protocols work, and how all these things are connected, and what are the various functional blocks of this unit. We're going to go into that in detail. So that's module 1. Module 2, which jumps into the what we call as the physical layer or the RF layer. So those who are already into digital communications and wireless communications would relate to this very easily. So Wi-Fi uses wireless medium. So basically everything is communicated over the air. We don't have any wires that are between the transmitter and receiver. So when a transmitter, this device, is transmitting to this device, which is a phone, the information is going over the air, right? From this antenna to the antennas that are inside this device, right? So how does that communication happen, right? There is so much technology behind it. How this communication happens, how do you make sure the communication happens at a certain distance without interference? How does the transmitter listen to the receiver properly? What frequency do they communicate in? What modulation rates, coding rates they communicate in? And various kinds of technologies behind it. How the signal propagation works, how reflections, refractions, diffractions, multipath, various kinds of things that work between when this guy is trying to communicate with this guy. So we'll cover all of that, all about that in the WLAN 5 layer details or physical layer information, right? So that's module 2, and there are many areas that we cover there. Module 3 is probably one of the most important, which is what we call as the layer 2. For those of you who come from a networking background would understand what the network layers are, layer 2 being the data link layer. So we, in this case, we call it the medium access control layer or the MAC layer. And there is so many things that happen here. Like, for example, this is a Wi-Fi router. When you try to connect to a Wi-Fi network, you go to the list of Wi-Fi networks, and it shows SSID TP-Link, right? So then you select the TP-Link SSID and you say connect. And when you connect, then you connect to the Wi-Fi network, and then you get an IP address. So what is going on behind the scene when that is happening, right? How do you actually see that there is a Wi-Fi network? How does the phone actually recognize that there is a Wi-Fi network available? So there must be something that this Wi-Fi router does for your phone to be able to see that there is a network, right? So which means that this guy is going to broadcast some messages, and they're called beacons, right? Just like from a lighthouse, there is beacons, messages sent from a lighthouse for the ships to be able to see, to go to a specific place. Similarly, there is something called as beacons that these Wi-Fi routers will broadcast. And then when the radio on this device receives those beacons, then it will be able to see that network. So how does that work? How does the concepts of when this device connects, how does the connection process work? How does security work? When there are multiple devices like this trying to connect, let's say there are 10 devices in your house, they're all trying to connect to the Wi-Fi router. How do you make sure when they're all trying to transmit data that they're not fighting with each other, they're not colliding, right? How do you make sure that they all share the medium well? So there's a lot of technology behind it underneath, and that's where we're going to talk about carrier sensing, medium access, connection, data transfer, different types of frame formats that you see that actually make the wireless communication or Wi-Fi communication happen, right? So we're going to know all the details in that module. And then there is security in Wi-Fi. So this is again a very important aspect. You don't want anyone to basically snoop into your Wi-Fi connection and basically steal your information. So you want the connection between a client and a Wi-Fi router to be very secure. So there are many different types of security protocols. There are certain protocols that you would use in your house, in your home connection, and there would be certain types of protocols you would use in an enterprise network, in your office. And how does that various kind of security protocols work? Different types of security methods, and how do you generate keys that are used for encryption? How are the keys exchanged? All those details we're going to talk about. And then we're going to talk about various types of attacks you would see in a Wi-Fi network, DDoS attacks, man-in-the-middle attacks, and so on. And then we're also going to talk about connectivity between Wi-Fi and cellular networks and how does that happen. Right? So that's all part of the security section. And then there will be advanced topics in module 5, week 9 and 10, 11, 12. So this is going to cover so many other aspects of Wi-Fi technology, how multiple Wi-Fi access points are managed in an enterprise network, how radio resource management works, quality of service, mobility, power save. And then there are new standards like Wi-Fi 5, Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7. Lots and lots of features in that area. We're going to talk a lot about those things. Smart Wi-Fi features, Wi-Fi mesh networks. There is one session on Wi-Fi monetization. How do you make money from Wi-Fi? Unlike cellular, in the case of cellular, when you actually connect to the cell network like Airtel or Reliance, you actually buy a plan, right? And you pay the money for using the cellular network. But normally, you don't directly pay money to actually access a Wi-Fi network in most places. So how do you make money when you're deploying a Wi-Fi network? So there are various ways you can talk about that. So there's one session on that. Now, some of these, if you're a complete beginner to this technology, you might find some of these terms overwhelming. So some things that you have never heard of, but don't worry, we'll try to make it as simple as we can. And for those who already know all of these things, we will still try to explain it to you in a way that it is easier to understand and maybe potentially easier for you to explain to someone else as well, right? So we'll try to keep it interesting for everyone. And then the last module is going to talk about troubleshooting tools and so on. So we'll talk about this in the next 2 weeks. How to stay connected? Of course, there are these ways you can connect to the web page. You can download the material. You can join the WhatsApp group. There is this weekly wireless wisdom WhatsApp group where we are going to share information about the course. You guys can post questions. The organizers will be able to answer, or anyone else in the group who are experts can answer, and certainly discuss more about the material that's covered in this course. So for those who are new to wireless and new to computer networking, I can tell you that it's not going to be easy. In 1 hour, I will not be able to teach you a lot of this. You have to do a lot of work if you're interested in this area. You have to go back and listen to this and go to do some research online and learn more about it yourself, and then come back and post questions. And that's how you can learn better. So we just did a quick breakdown of the people who registered for this course, and this is a complete surprise to me. I was not expecting this at all. But as of this morning, we have more than 1,000 people who registered for this course from a lot of places in the world, almost like 30 countries. So I put that on the right-hand side here. And it turns out that I would say a majority of the people, almost 60%, are working professionals who are junior engineers who just started their career in the area of computer networking and Wi-Fi. And then there are lots of engineering students also. And majority of the people are from India because of the time we are doing it at 4 to 5 p.m. And also the interest is from here. But again, if there is more interest from other parts of the world, we can try to do this in different time slots as well. So about almost 85% of the people who registered, of the 1,000 people, are from India. But then there are people from other countries as well. And most of them are new to this technology, so we'll try to keep it. We'll try to keep the course accordingly. Okay, so we'll jump into module 1, introduction and history of Wi-Fi and how the technology evolved. So the first slide I have here is I sourced this content from this place called Wi-Fi Forward, but they actually did a very good job of summarizing over 20 years of Wi-Fi history. So if you look at computer networking in general and the wired networking in general, it's been around for like 50, 60, 70 years, and it has a long history, or even more than that. But if you look at Wi-Fi, Wi-Fi is fairly new. Wi-Fi has been around really only for the last 20, 25 years or so, right? So in around 1985 is when it started. The FCC, which is the Federal Communications Commission, which is basically the governing body in the US that regulates the use of RF spectrum, right? So why do you need to regulate use of RF spectrum? Because when you transmit in a particular frequency, you don't want others to interfere with you. So for example, if you're using FM radio, right? So what you do is there are certain set of frequencies that are allocated for FM radio communication, and only FM radio communication can use those frequencies. When you tune into like 101.5, 101.3, like different radio channels, those are actually frequencies that you can tune into. And that frequency is used to communicate that information, that channel basically, right? And no one else can use it. Right? So there is a body called FCC which would regulate who is going to use what frequencies in what region. And so in the US, FCC does that. So what happened is around 1985 timeframe, FCC actually opened up some spectrum for what we call as unlicensed use. That means that you don't have to go reserve or buy spectrum from the government. It is free for anyone to use as long as you follow certain rules. So the rules would mean that you cannot transmit at more than a certain amount of energy or certain amount of transmit power. So when you don't transmit with more than a certain amount of transmit power, your range will be limited, small. So when your range is small, then you're not interfering with someone else who's using the same frequency, right? So as long as you follow certain rules, they opened up the spectrum for unlicensed use. So many people can use it for any type of wireless communication. And that's when it all really started, right? And then people started using that frequency for various applications. So one of the first applications that came up, set of applications that came out are microwave ovens, garage door openers. People were trying to in the US it's very common. So you have in some places in India as well, you have this small device which is what we call as a garage door opener. As the car comes close to the garage, you click on it and then it opens the garage, right? So that communication is happening wirelessly. Like baby monitors, cordless phones, all these devices started coming out and they were using this unlicensed spectrum, right? Which was opened up by FCC. And then in around 1989 time frame, the first wireless router, and this is pre-standards. There were no standards at this time. So even before the standards were there, the first set of Wi-Fi routers were developed by companies like Proxim Wireless. I still remember many years ago, I used to visit this company, and this was the company. They don't exist that much around anymore. I think they still have an office in Hyderabad, if I'm not wrong. But they were one of the first companies that were developing these Wi-Fi routers along with a few other organizations. And they developed the pre-standards versions of that, right? And then people started using it for various other applications like digital payments and cash registers and things like that. They were using this technology, cordless phones and so on. And around 1995 time frame, there was one of the first college network was installed using Wi-Fi, and this is again pre-standards. So when I was a kid, like many years ago, in the 1970s, 80s, and so on, most of the research was happening in colleges and universities more than in the industry, right? The number of industries were less at that time. So any new technology, in fact, invention of the internet, the usage of the internet, and all of that really happened a lot in the universities and colleges, right? So there was a trial network that was, I believe, was installed in Carnegie Mellon University around 1995 time frame. Again, this is pre-standards, and they were probably the first Wi-Fi network that's installed. And then in around 1997-99 time frame, the first standard came out from IEEE, and it was called IEEE 802.11. There's an entire section allocated for standards. So I think there's like two sessions from now. We'll talk about the standards more at that point. And then the standardization started, right? And then around 1999, this was one of the biggest turning points for Wi-Fi. And this is when Steve Jobs got up on the stage and he introduced this Apple iBook. This was around 1999 time frame. And this was the first device that was commercially shown as a device that can connect to the internet wirelessly, right? So there was this nice video. I included this link to the video in the references slide. You should go watch it. But in this video, he talks about he actually connects to the internet using his laptop by putting it on a desk, and then all of a sudden he takes out the laptop and starts walking with it, right? And remember, this is 1999, right? Long time back. And he starts walking and he starts browsing the internet, and the crowd just like erupt and they go crazy, right? Because they've never seen something like that, where you can actually connect to the network on a device like a laptop without any wires at all, right? And that's really what like kickstarted the Wi-Fi to really pick up as a very famous technology. And then over a period of time, millions of Wi-Fi chipsets were sold. And then laptops started slowly replacing desktops. Many of you who are very young may not know this very well, but early stages, it was all desktops, it was all monitors and keyboards and big CPU machines and things like that many people were using. All of that was gone, and now people started using laptops. And the predominant way to connect to the network when you have a laptop is through Wi-Fi. And so that really catapulted the evolution of Wi-Fi and the adoption of Wi-Fi. And then around 2008 or so, the touchscreen smartphones came out again from Apple, and that also really kind of boosted the evolution of and adoption of Wi-Fi a lot. And then again, 2010 is another milestone. Tablets came out, and tablets were purely using Wi-Fi to connect to the internet. So at least the smartphones would connect to the cellular network, but most tablets would connect only to Wi-Fi. And so because of that, again, Wi-Fi started growing even more. Around 2015 timeframe, over 10 billion Wi-Fi devices were sold. And this is the time when it was not just smartphones, laptops, and tablets connecting to Wi-Fi. It is a number of other devices. It is your medical equipment. It's your wireless printers, your scanners, your IoT devices, your TVs. So they all started slowly connecting to Wi-Fi and using Wi-Fi. And so that made Wi-Fi even more widely adopted. And then, of course, we all know that as we get into the late 2017, between 2000 and so on, now we have these virtual reality headsets and all kinds of other devices that use Wi-Fi. And Wi-Fi continues to contribute to the world's economy, and the speeds keep increasing, and it's competing with. There is one stat that says that about almost 60% of the internet traffic now runs on Wi-Fi, which is amazing, mind-boggling, right? So there's all this data that's there to show how ubiquitous Wi-Fi is, right? So that is the reason why we're learning about Wi-Fi, and we want to understand how this technology works, why did it become so famous, and how does it function so well, right? So some initial hardware that was around when Wi-Fi came out is one of the first set of Wi-Fi routers. You can see that it's like a big box. And then what you see on here is basically the network interface card or PCMCIA card. So we used to have these cards. I used to use this also early on when I was testing Wi-Fi. So I would take a card like this, and there's a PCMCIA slot that you connect to your laptop, and that's how you connect to the Wi-Fi network. Now, in most cases, most laptops, all the radios are built into the system. Right. So we'll talk a little bit about the technology evolution. We talked about the business evolution of Wi-Fi and how it became so famous and all that. We'll talk about the technology evolution a little bit. So when it comes to the evolution of Wi-Fi technology, there are two areas in which Wi-Fi is predominantly used. Right. One is residence. We all use the Wi-Fi in our homes, and then the second one is an enterprise. So what does an enterprise mean? Enterprise mean it could be your office. Right now I'm using Wi-Fi to deliver this presentation, or it could be a shopping mall, it could be a stadium, it could be a restaurant, it could be like a hospital, it could be any of those, right, where you have Wi-Fi networks. So how did Wi-Fi evolve in these two specific areas? Residential is one area, and enterprise is one area, right? So first I'll talk about residential, and then I'll talk a little bit about enterprise. So in the 1990s, in that decade, we started off with that first standard I was talking about, 802.11 standard. And then the data rates were around 11 Mbps or so. That was the early standard. We used to call it 802.11b standard. So, and those Wi-Fi routers look something like this. Right? So this is like a Wi-Fi router, as you can see. They look like this, and they would connect to the internet using what we call as a POTS line or a phone line, and they use DSL or phone dial-up technology. We used to call it dial-up, where you actually used to have a phone line. So I'm not sure how many of you remember or know about this, but it used to be landline phones. We used to use a lot before cell phones and cordless phones and cell phones came along. And these landline phones would they're called POTS lines, and they basically we would connect to the internet using the phone line, right? And so basically this router would connect, there should be like a phone line jack here, and you would connect the phone line jack to this one, and that is how we would access the internet. And the speeds are very low. Even though the Wi-Fi router can do 11 Mbps, the phone line typically would do like 56 kilobits per second or something like that, or around that range, or maybe a few megabits per second, right? So that was very slow. And the early version of Wi-Fi was used for basically email. So you'd have one desktop or one laptop in your house, and then you would use it for email, really. And you never cared about latency. If your email is delayed by a few seconds, no one cared. And the cost of the Wi-Fi router was also pretty low at that time. So I remember we used to pay, $20, $30 in the US for a Wi-Fi router. Just go to the electronic store and buy a router, right? It's pretty cheap. And then it started evolving in the 2000s. We started getting better Wi-Fi routers that looked like this, right? So this is an example that I have here. These routers were able to do much faster speeds. We went up to 1 gigabit per second. And then what happened was, in the 1990s, we would go to the electronic store and buy a Wi-Fi router. But in the 2000s, the operators started deploying Wi-Fi at large scale. So what does that mean? Like in India, for example, Airtel or Reliance or some of these companies would say, okay, we are now going to provide Wi-Fi internet to you, right? So already the cable companies are providing TV. So for those of you who remember cable TV, when we grew up, we all watched cable TV. So the same, basically the provider would provide cable TV, they would provide phone line, and then they would provide Wi-Fi for data, right? So they would provide voice, video, data packages. So voice is coming from your phone line, landline phone line. Video is basically your cable TV, and then data is coming from your Wi-Fi. So they would provide this modem where you can connect to that, and then they would provide the Wi-Fi router also, and you get basically phone, video, and also internet, right? And that was predominantly the use case in that time frame. And then the applications started becoming more and more, and the devices started becoming more and more complex, and houses started becoming bigger and bigger. So in the 2000s, an average home had like 1 or 2 devices, maybe a laptop, maybe a desktop. But in the next decade, an average US home had 20 to 30, maybe even 40 devices. When I was living in the US, I would have somewhere between 20 to 30 devices connected to my Wi-Fi network. Right, my TVs were connected, my laptops, tablets, phones, thermostat, vacuum cleaner, doorbell, garage door opener. They were all connected to Wi-Fi, and this was like 6-7 years ago. Right? And so there are lots of devices that are start connecting to the Wi-Fi network. We came up with this whole concept of OTT, which means that all video content, high definition, 4K, 8K, is streamed over Wi-Fi on the internet. And so everything became very important. Wi-Fi became very important. It's not just your email anymore. If Wi-Fi doesn't work properly for a few minutes, then you will see that the video is jittery, the video will get stuck, and people are not happy, right? And as the houses started getting bigger, you had coverage issues with Wi-Fi. So you needed multiple Wi-Fi routers at home to cover your house better, right? So then we started deploying these larger and larger Wi-Fi routers. So this is an example of, you can see how big this is. It's probably as big as my head, right? This is a Wi-Fi 6E gaming router, right, from ASUS, I believe, right? So these are quite expensive, and they have lots of antennas, and these are specifically used for gamers and all of that to provide better range, high throughput, and so on, right? And then these devices came along, and now of course you can see that they're a lot more expensive than the devices that were there before. Right, and then you can see these type of devices you see in the picture, right? These are mesh routers. So you can set up these routers, multiple of these in various locations in the house, and without any wired connectivity, they will connect with each other wirelessly, and they'll extend the wireless range for you in a house. So for example, if you have this router in your living room, and you're going to your balcony and trying to connect to the Wi-Fi network, you're not able to connect to it because of the range problem. You can use an extender like this, and you put an extender in your kitchen, and the extender would connect wirelessly to this router, and then it will extend the Wi-Fi range. So like this, you can use mesh networks, and they came up with these concept of mesh networks, right? And then as we went along in the current decade, we are now up to like, and as we went along, the speeds also started increasing. So now we are at 50 gigabits per second speed, and we are at Wi-Fi 7. Now we are looking at AR, VR, home automation, potentially connecting 40, 50, 100 devices in the house to the network. And we now have even bigger. So I can barely carry this. So this is the Wi-Fi 7 router from TP-Link. It's not supposed to have these antennas. We actually opened the case and installed some external antennas. But this is huge, right? You put in this house, and this will give you, in theory, like Wi-Fi 7 technology can give you up to 50 gigabits per second. But this router, because of certain limitations, right now we're able to get about 3 to 4 gigabits per second throughput. So that is a lot of throughput, right? So if you're doing a high definition video stream, let's assume it takes about 25 megabits per second. So now you can run about 150 or so parallel video streams, high definition video streams, if this device works properly, right? And that is the amount of throughput this can provide. And it can provide better range, it can provide multiple bands and all of that. Now, all the technology that's inside it, we will learn as we go. I'm only giving you the very high level basics right now. Right? So that's the residential. Now coming to enterprise also evolved extensively. So like enterprise also started with 11 Mbps standalone APs. So you'd go to an office and you'd find one AP installed. We call it access points in enterprise network. We don't call it routers. So when I say AP, I mean an access point, a Wi-Fi access point, right? And so again, it was for, it has very low security. Security is a big problem. And we'll talk about how the problem is solved over a period of time. And then we started deploying Wi-Fi access points and routers in large scale in networks. So for example, some of you are from universities and colleges, right? So let's say you take a college hostel or a huge building which has so many classrooms, and you want to connect it, create Wi-Fi network there. So you'd install all these Wi-Fi routers in all the ceilings, and they all connect to some central controller, because if you want to manage all of them, you cannot manage each one individually. So if you have to install a security key, or you have to install a basically upgrade firmware or something like that, you cannot do it on each one individually. If there's only one router in your house, in enterprise, it's easy. But if there are 100, so you cannot manage each of them individually. So they all need to connect to a controller. And so basically they form this network and they all connect to a controller. And then the controller will manage all these devices and provision all these devices and set policies and all of these on these devices. And so the concept of a centralized controller that is in the wiring closet, that came along. And along with that came an IT team. So because these devices were very complex to manage and configure, they needed to hire really talented IT people, right, to actually manage these networks, right? And it was quite complicated to manage, but it was still done that way. As we came into the next decade, we started this whole concept of cloud. Everything started going into the cloud, right? The internet speed started to increase a lot. So what that meant was you can push the concept of a server into the cloud. The server doesn't have to be in the same location as where the clients are. The server can be in the cloud because the internet speeds are very good, right? So what that means is it allowed, the evolution of internet speeds allowed us to push the controller into the cloud. And that allows us to manage from a centralized location multiple sites. So let's say there are multiple colleges and you want to manage the Wi-Fi network in all these colleges from one central location, right? By pushing the controller to the cloud, you can manage it easily, right? And so this cloud controller technology came along, and pretty much everyone started implementing things in the cloud. The physical access point Wi-Fi router is still in the building. They're all installed in the building, but they're all connected through switches and the internet to a controller in the cloud, and the cloud will manage all these routers basically, or these access points. And then if you look at the current decade, now it's all about AI ML. So a lot of you, if you're students, you're all taking AI ML courses and all of that. So there is more machine learning, there is more artificial intelligence in Wi-Fi networks now, right? And what does that do? The more artificial intelligence and the more machine learning you do, the more self-organized these networks are and self-healing these networks are, which means that they need lesser people to manage them, which means that you don't need this highly paid IT person IT guy. You don't need to hire the highly paid IT person. The network will automatically manage itself. It will find the fault, it will learn from the fault, it will fix it, and it will go on, right? And so that is the value that these companies are now providing to the customers. So if you look at how the technology evolved, and if you look at the slide, I'm calling it hardware to software. In the early generations, it's always about the hardware. It was about how good your antennas are, how good your transmission range is, how good the access point looks, and what kind of processing power it has. It was all about that. But now as we evolved, all the differentiation and the value started coming into software, right? And now companies differentiate each other. They all use the same hardware pretty much. And the company that provides better software features would actually would do better, right? So this is a kind of a general overview of how the technology evolved. As we can see now, Wi-Fi is in many industries, pretty much everywhere. It is not just offices, healthcare, smart cities, hotels, public Wi-Fi, education, apartments, oil and gas, retail, offices, transportation, agriculture, smart home, mining, lots and lots of places, right? Manufacturing, defense, and so on. So if you look at the Wi-Fi technology life cycle, all of you are seeing this one, right? Okay, this is a Wi-Fi router that I have in my hand. But how did this get built, right? Is what I'm going to talk about a little bit in this slide, right? How did it get to this point, right? So there are so many organizations that work to actually get this to a point where I can use it in my house, right? So how did that happen? First step is you come up with a use case. Like for example, the current technology, let's assume that it doesn't give you very high speed, right? Or it doesn't give you very good security, right? So now someone says, okay, this current technology generation is not very secure. So let us write a document or a request for authorization where we are going to write a spec or write like a proposal to improve security on this one. So some companies or group of companies will come up with a basically a list of use cases which they convert into a document, right? And submit that to the standards body and say, okay, we are going to create a new standard that addresses these 5 problems. It gives you better speed, better security, better range, and a few other things. So they come up with the document initially. And then there is the standards body, IEEE, and there are a lot of member companies in IEEE. They all sit together and they look at these things and they do a lot of back and forth and they come up with the what we call as the standard and or an extension of a standard. So the base standard then gets extended. And there are a lot of standard extensions to Wi-Fi. I'll talk about that in the coming sessions. Okay. And then in parallel, there is something called as you need to build the next generation Wi-Fi chip, right? So to build a chip or a system on a chip, you need to first do some simulation to check that the technology will actually work. Whatever is in the standard can actually be implemented. So before the standard concept goes into taping out a chip, there is an intermediate step where we do simulation. Like for example, anyone who comes from an academic background, there are lots of simulation tools. Like when you're trying to prove a concept or write a paper, you would use some form of simulator where you simulate certain things and then from the simulation you come up with some results and present it, right? Similarly, there are pre-silicon design verification companies. They use these IDE tools to actually simulate these systems and test if they actually work. There are companies like Cadence, Mentor Graphics, Synopsys. Some of these you guys, if you're students, you might have applied for jobs in these organizations, right? And then there are companies that develop the Wi-Fi chipsets or the system on chips. There are companies like Qualcomm, Broadcom, Intel, MediaTek. These guys will build the actual chipsets that go inside this Wi-Fi router. So that is the chip or a system on chip that does all the technology that we're going to talk about. It has a radio interface. The radio is going to transmit, it's going to receive, it's going to implement the physical layer, the MAC layer. All the things we're going to talk about in this course are implemented at this level. And then the chips are taken by companies like TP-Link. So you see TP-Link is one organization. So they take those chips or system on chips and then they build these APs, right? And they actually lay out the boards. On the boards, all the components, they'll run all the cables, they'll design the antennas, they'll design the case and everything, and then they'll build a product like this, right? And there are many companies. Cisco does it. Cisco is one of the biggest market leaders. Of course, many of us know Aruba, Netgear, ASUS, TP-Link, so on. There are hundreds of companies. I would say 100+ companies that actually do this work. And then once you kind of build the early version, even before you get to this stage, at the board level itself, when it's in a board, then you go do proof of concept. Then you go do plug fest. As the new technology comes out, you need to make sure that this Wi-Fi router can connect to a Wi-Fi device, right? And so you'll have to do some initial tests, and there are organizations like Wi-Fi Alliance and so on that do this plug fest, right? And then you go through certifications. So as you build this product, you have to go through FCC certification to make sure that this radio is complying to the requirements. Remember, when I said these access points use unlicensed frequencies. So what that means is there are some restrictions. They cannot transmit at more than a certain power, so that you give other people to chance to reuse the frequencies, right? So which means that you need to go and get a certificate saying that yes, this particular access point or this particular router indeed cannot transmit at more than so much transmit power, and for that you need a certificate. Similarly, you need UV, UL certificates to make sure that it operates at a certain temperature level and certain humidity levels, and it doesn't have any spurious emissions. It doesn't emit signals in other frequencies that it's not supposed to use. So lots of certifications that we need to go through, right? And there are certification bodies for that. And then of course there is manufacturing. You want to manufacture this in hundreds of thousands of units. So then there are organizations, companies that actually build these modules in large scale. They have factories. A lot of these factories are in China, Taiwan, but now in India, actually, we're starting to do a lot of manufacturing in Chennai, I believe in Manesar, in Gurgaon. In certain places, there are actual factories now that actually produce these access points. These are access points at large scale, made in India, through the Made in India program, right? So that is that lots of companies that do that. Right? And then there is deployment. So once these devices are developed, someone like an Airtel or a Reliance or a Comcast, they would say, okay, they'll put their logo on here and they'll sell this to you to use in your home, because they're providing the internet connectivity to your home. They're also going to provide this router to you, and they're also going to manage this from their network. So these are managed devices from the Airtel network or from the Reliance network. So that is part of deployment, right? If you are deploying basically in enterprises, then you have to do site surveys. You need to do planning. So let's say you're deploying Wi-Fi network in a large building. You need to figure out how many Wi-Fi routers you need to cover the building. How many, where do you have to place the routers to get proper coverage? So all of that planning, deployment, there are lots of companies that do that. And then there is post-deployment. Once you do the deployment, you need to actually go manage the network. If something goes wrong, some intruder in your network, or the performance has gone down on a particular Wi-Fi router a lot, what is happening? Why did that happen? Right? Some new device came into the network and it is causing interference to everything else. What happened? Okay, how do we solve that problem? So these are all post-deployment issues, right? After you deploy the network, how do you manage those things? How do you test those things? How do you troubleshoot those things? Is all part of the post-deployment. So this is the entire ecosystem of the technology, and there are hundreds of companies that actually work on this ecosystem all around the world to make this technology happen, both at the residential level and at the enterprise level. So lots of Wi-Fi devices that are used, as I mentioned. One of the reasons why Wi-Fi became so famous is because there are so many devices. It's not just your laptops and smartphones. It's like gaming devices, cameras, printers, set-top boxes. Now we have Wi-Fi in refrigerators, microwave ovens, sprinkler systems, home robots, right? Blood pressure monitor systems, patient monitors, infusion pumps. All kinds of devices have a Wi-Fi in them, and they all connect to the Wi-Fi network. And that is also the reason why Wi-Fi is used so much. In transportation, we use Wi-Fi heavily. I have in the next section, in the next module or the next session, tomorrow, Thursday session, I think, I'll go into a little bit more detail into the various places in where Wi-Fi is deployed. We'll cover more of that section. So this is the only technical slide in this presentation. So at this point, those of you who are not very technical in this field are probably enjoying this conversation, and some of you who are already very knowledgeable in Wi-Fi might get bored, because I mean, I'm not really covering a lot of the technical aspects. I promise you that we'll cover all of that in the coming sessions. This is more of an introductory presentation to talk about the business side of things. This is the only technical slide I have. I will not go through all the details, but you will understand this in more detail as we go through the next few sessions. So as Wi-Fi evolved over the last many years, we started from Wi-Fi. The early versions were not called Wi-Fi, so that's the reason why we started from Wi-Fi 4, from when the Wi-Fi line started. So there's Wi-Fi 4, 5, 6, and now we are at Wi-Fi 7. And as we went through all these generations, each generation has about, I would say, 3 to 5 years of lifetime. And as the technology evolves, a lot of things change, right? The amount of frequencies allocation has increased. So there are more frequencies available. The number of antennas increased, which increased the throughput you get. Again, I'm using very simple terms, but we'll get to the more technical terms later. So you can see that early version was only 4 antennas. Now you can go up to 16 antennas, and then you get very high throughput. You're using more complex modulation rates, and because of that, you're getting better throughput. We started around 600 Mbps in 11N, and now you're at about close to 50 gigabits per second throughput, and so on. So all these things evolved, and new technologies, security became better, and all these things evolved. And again, we'll cover each and every of these aspects. Every one of these is probably one session, right? And there is more details coming in the coming sessions. So I think this is the last slide. So why is Wi-Fi technology so successful? Again, to summarize, first thing is low cost when it comes to cellular technology, which is very costly to install and very costly to maintain. So if you want to install a cellular network, you need to find a piece of real estate where you can install a base station, right? First, you need to install a tower, and the tower you need to put a base station. The base station is very expensive, right? And then you need to basically set up an entire network behind it. Now with Wi-Fi, all you have to do is basically buy a Wi-Fi router and then set it up in your house, and you're up and connected wirelessly, right? So the cost of installation and maintenance is much lower when it comes to Wi-Fi. Another big advantage with Wi-Fi is it works with IP networks. So those of you who come from a computer networking background, we all know that the entire internet is a huge IP network, right? It uses TCP/IP technology, right? So Wi-Fi is just really the last hop. So you have internet coming using TCP/IP, and it connects to one of the wired ports on this baud router, and it makes the last hop wireless. So basically, the connectivity between this and this is wireless. But beyond that, everything is wired, and everything is just standard computer networks, IP networks. So because of that, Wi-Fi is very extensible. It's very easy to use. You don't need to create an entire network. On the cellular side, for many years, there was an entire parallel network that was not based on IP networking, right? And so they had to create so many network elements to actually make cellular network work. With Wi-Fi, you don't need to create any network element behind this. This is the only thing, right? Everything is already there. The entire internet is there, routers are there, switches are there, everything is there, right? So that makes it very simple. It uses unlicensed frequencies, so that means that you don't anyone can use the frequencies. You don't have to pay a lot of money to the governing bodies to buy for spectrum. It provides very high data rates because of the technology. We'll explain how it provides very high data rates in the coming sessions. And it provides enterprise-grade security. It's highly secure. Many security protocols implemented. Again, we'll talk about that in detail. Easy to deploy. I talked about how it's easy to deploy when compared to cellular networks. And it can scale, right? I mean, there are networks that have thousands of Wi-Fi routers. If you take a large cricket stadium, I think there are some cricket stadiums now in India also that have Wi-Fi networks installed. It's a huge stadium or a huge shopping mall. You'll need hundreds of Wi-Fi routers or access points installed, and you can scale very easily. And you can put the controller in on-premise, or you can put it in the cloud, and you can manage them very easily. And it scales, and the network can scale to huge volumes. And then the technology itself is very open, right? And this allows us to actually make so many different types of uses of technology, not just for browsing the internet, but Wi-Fi is used in many areas because the technology itself is very open. So here are some references for the content that I covered today. Again, these slides will be posted, the video will be posted, and you can actually go click on some of these links. I think there are some really nice books also that you can read. If anyone is interested, please send us a message on the group, and we'll also suggest some books that you can start reading on the Wi-Fi technology to follow along as we go through the sessions. and then we'll also post references for each presentation. So that's all I have to present for the first session. Hopefully you found this useful, and it's back to the organizer for the quiz. Awesome. Thank you all for joining, and hope you found this session useful. Please do comment in the WhatsApp group if you have any comments, if you like the session, or if you feel like we can do something better. I was reading through the comments, and someone said I need to speak a little bit slowly. Point noted. We'll try to speak slowly. But any comments you have, good or bad, please share in the group, and we'll try to continue this session. Hopefully this is useful to everyone. Thank you again, everyone, for joining. Thank you.
Thanks all.